rejecting a sample, but we're not announcing for inserting a sample, but we're not. So then the next step is to lock. Now the lock signal on the capillary NMR is weaker than it is on normal because we have so much less solvent. So after you lock, it is, and this maybe you may see that this means that it didn't flow to standard shims. That's okay. So we can do automatic lock, and it should lock in the normal way. But if the signal is noisier than you're used to, don't worry about it too much. So if it's really noisy, then that can be an indication that there's a problem with your sample. Either there's an air bubble in the way or something is wrong. This is reasonable for a core form on this probe. This amount of noise. Okay, now for shimming, I'm not going to cover that right now, but shimming on the capillary NMR probe is very different than it is on the normal NMR probe because the capillary is oriented perpendicular to the field, whereas the normal NMR tube is parallel to the field. So the main shims that you would use would be y, z squared, x squared minus y squared, xy, and to a lesser degree x and z. So shimming with your normal z and z squared will not improve the shims. Probably the best thing to do is to click RSH and load in the cap NMR shim with the solvent that you're using. And if you want to try to improve it beyond that, you can read the guide on how to shim on the capillary NMR system. In this case, I think the shims are okay, so I'm just going to click shim OK. And then come back to the automation system. It's doing the receiver gain adjustments like normal, and then it's going to go in and start collecting data like normal. Just like on a normal system, if you want to, you can click on spectrum after it started to look at a snapshot of the spectrum while it's underway. So I will go ahead and do that. And it should bring up the spectrum as it normally is. You should be able to get a data set that looks reasonable. The line width might be a little bit broader depending on your shimming than it is on a normal NMR probe, but you should be able to get under 2 hertz line width. And remember that the capillary NMR probe is less sensitive than a normal probe on a concentration basis, but the volume is much, much less than it is on a normal NMR probe, which gives you the advantage in signal for the total amount of sample. But remember that your concentration needs to be at least as high, and probably twice as high as you would use on a normal NMR probe for the same amount of signal averaging. Once the spectrum is finished collecting, and then it's going to tell you to eject the sample, but again, you can just ignore that. You can stop the run. Yes, you really want to stop. And then you can close this to make it ready for the next person to say no. So now it's ready, and your data should be collected just like it is on a normal system, so it should be under your username. And you should be able to double click on it and see the data that you collected. Okay, so we're done here. So the last thing to do is to remove your sample and get the system ready for automation again. Okay, now we're going to try to recover our sample, so I'm going to take off this union. If you want, you can try to wash out anything if it has come out of here, so that you don't lose any of the material that might have touched the union. In this case, I'm just going to put the inlet into a vial. I'm going to get the syringe out, loosen it, and I'm going to draw it up with some clean solvent. And you'll want to probably draw up more than the 25 microliters used before. I'm drawing about 50 microliters here. Put it in and go ahead and push it through. If all goes well, you should see a bubble forming on the outlet. So now we've recovered our sample. So a good idea is to flush out the solvent that's remaining in the probe. If you want to, you can flush this into your vial just to make sure you've captured the last remaining bits of whatever's in there. So I'm going to reattach the adapter that goes to the lure lock. The lines from the probe, so disconnect the adapter, put that back in the box, disconnect the inlet and the outlet lines. These should be clean because we flushed them through. If you did not flush them through, please clean them prior to putting them away. And then we want to reconnect the automation inlet line. Again, these just need to be finger tight. There you go. And the waste line. After putting away all your materials is to flush out the lines from using the automation system to make sure that everything is ready to go for the automation system. So we'll go back there and I'll show you how to do that. Okay, now that we've reconnected the automation system, we need to get it ready for use of the automation system. And the main thing we need to do is flush out the lines using the syringe pump in the automation system with chloroform for the solvent that's loaded in the automation system. To do that, you come to the screen here and go to the run process window. If this isn't running running, you can restart it here with this one first run process icon, but it should be running already. And then we can go to pumps, and the HTSL, CATL3 is the option that we want to choose here, and this will open up direct control over the syringe pump. So what we want to do is flush the syringe pump. This will cause the syringe pump to empty and then refill. Down here, this is a little graphical depiction of the syringe pump. So right now, the syringe pump is full of solvent, and as we flush it, it will slowly move this way, dispensing solvent into the probe. When it gets to the end, then it will refill from the solvent reservoir until it's full again. So I'm going to press flush, and we can see now that it's flushing, and it will empty out. Now, it takes quite a while for this to happen, so I am going to wait for it to happen and come back after it's finished. Okay, now that we've waited, the indicator went all the way to empty and then refilled, and it's almost to the end of filling, so we will wait for it to finish filling here. That means that the syringe has refilled with solvent from the reservoir down here. One thing you can check to make sure is that there actually is solvent in the reservoir. The chloroform we're using reservoir 2. If the solvent is very low or empty, please let me know. In this case, it's fine. So we come back up here, and now it says ready, so it's been refilled. You can close this direct control window, or you can leave this run process window open. If you close that, it will lose communication with the automation system. So leave that open, just minimize it. And then make sure that the solvent conditioner is running. That also blanket nitrogen over the solvent, so that should be running in the background. And then the web page should be available here for somebody to log in. Now it's ready to go, and next we're music automation.
Hey, this is Sunil Kumar, and today I'm going to show you how to run a successful ITC experiment. And this is ITC instrument, and it contains a reference cell, which you can see here, and a syringe. So we're going to run an experiment, and it is divided into 5 parts. First one is we're going to wash the syringe, wash the cell, and then we'll fill the solution in both syringe and cell, and then we will set up an experiment on the monitor, and we will start. So first of all, if you see, you will find this instrument, the syringe in this position, and what we have to do is we will wash it, and the commands are controlled by the monitor. We have to wash the syringe, we have to come to the monitor, and this is the software of this instrument, and if it is not open, you can always open it. It's on the desktop ITC 200, and then what you do is there are several tabs on that, so you have to go to instrument controls, click that, and then you will find the different commands here. So we are looking for syringe wash. You can see here, you click the syringe wash. It will ask you to please connect the syringe, and then since the syringe is already on wash position, you can see this is the wash position, and there is another position which is the rest position. You take it out, this is the rest position, and if you have to load the solution, that will be the third one, which is the loading position. So right now we have to wash it, so we will again take it back to the wash position, click that OK, and you can see it already start washing the syringe. So now the next step is now to wash the cell, and we want to use this plunger to do that. So there's a hole in this box. This is for filling the solution, so you carefully put the plunger inside that, and softly, gently push it a little bit. And then one of the tubes, you have to wash the cell first with detergent, and then with water. 50 ml of detergent, and then 200 ml of water. So what you want to do is you have a tube open in here, and you put it inside the detergent, and with the help of this thermovac, you're going to wash the cell. So you stop. The knob of the thermovac is always in middle position, so you start it by pushing it towards the right. Here you can see started, and it will take a few seconds to start coming solution on the waste. Washing cell is concerned, once 200 ml is done, you take out the tubing, and then you can hold it in hand so that whatever solution left in the cell is come out, and then you can switch the knob of the thermovac at stop position, which is the middle position, and then put back this plunger, take it out gently, and then put it back at its earlier position, and this is how you wash the cell. And you can see over here now in the monitor, the washing of the syringe is also done. So the next step is now to fill the solution in both the syringe as well as the cell. First I'm going to show you how to fill the solution in syringe. So for that, there is a syringe here. So you first have to transfer the solution of the ligand which you want to fill in the syringe from bigger epilogue tube to the smaller tiny ones. So that's especially for this ITC. You can borrow from here some of them. Otherwise you can come here and transfer your solution from your epilogue tube into small ones. They are 200 microliter volume. So you transfer some of them into 200 microliter volume and then put it at the new position. And once you do that, now you go back to the monitor and again look for the command which is syringe fill. You can see here, click that, and it's going to ask to place the pipette in rest position. So you take it out from here and put it to the rest position. And now you hit OK and wait for the next command on monitor. And it will take 5-10 seconds, and then it will ask you to put the pipette in tight. You move the syringe to the loading position, and then you hit OK. So it will take less than a minute to do that. It's going to suck the solution up, back and forth, make sure that there won't be any bubble inside the syringe. And then we will wait for the next command. In the meantime, this is the next part to fill the solution in cell. So what you do is you take the syringe, which is sitting in front of the machine, take the solution and fill it. The cell contains 200 microliter solution. So ideally you should make 300 microliter solution or more than that. And now what you're going to do is you're going to fill the cell with the solution. So there is a center hole in that. So you slowly put the syringe inside and release the solution inside. So since the volume is 200 microliter in there, but our syringe contains more than that, so you make sure you overfill the cell, and then you kind of move the syringe a little bit so that if there is any bubble you introduce during the filling, it's going to go away. So you kind of move it for 10 seconds inside. Keep on doing that. A little bit up and down as well. And make sure you remove any bubble if you introduce. So after doing that, you suck the extra solution from the cell. So once you get this message after the syringe dry, you have to unhook the syringe from the tubing gently, and you take out the syringe and put it inside the cell. So after this you click OK on the screen for this message, and this is the process of washing the syringe as well as the cell and filling the solution in there. So the next step will be to set up an experiment. You have to switch from the instrument controls to another tab, which is the advanced experimental design. Click on that, and you will see the touch screen and some commands there. So now, a couple of things. One is total injections. Generally, you keep it from 25 to 35, depends on your need. Or you can see some old literature reports if somebody has done ITC on your system. And then the cell temperature, you can vary it accordingly, whatever temperature you want to run the experiment. And you are not supposed to touch these values. And over here you can fill the syringe concentration value. So right now it's 1 millimolar, so I'll just change it to 1 millimolar. And the cell concentration is 25 micromolar here, so it's 0.05. And you are not supposed to change further. So one more important thing is the volume per injection. So the syringe contains 40 microliter. And you need to make sure that you only have, let's say, 27 injections there. So you multiply this number with this, and it should exceed 40 microliter. Otherwise you end up messing up your experiment with bubbles. So you always double check the multiplication so that it won't exceed 40 microliter. And generally we keep 1.2 to 1.4 microliter of injections. But you can increase or decrease it accordingly. And the spacing, 180 seconds, which is 3 minutes. People do it up to 5 minutes as well. Depends on how fast or slow you want to go taking it. And you see there are all the injections there. You can check them. And once you are done with this, then the next step is to put the data in your file. So for that, you need to make a folder. And what you want to do is you go to shortcut data, and you make a folder here. So I'm going to show you how to make this folder with my name. I made a folder, and you can close it. Now you have to change the tab. You go to real time plot. You go to setup, and over here you double click on the data file path. Click on ITC, data, and then scroll to find out the folder you just made, which is here. So click that, and you do the same thing with the setup file path. That's it. So that's it. So now the experiment you are running will go in your folder. So Now you come to, again, advanced experimental design, and you change it to name whatever you want from your experiment, and you start the experiment. But before starting, you might want to double check all the parameters, like number of injections, temperature, and concentrations, and volume per microliter. Double check it, and you can start the experiment. So once you start it, the screen will change and will show the real-time experiment. So once the experiment is done, then we can process the data, and to do that we need the software, which is Horizon 5 or Horizon 7, whichever you have. I'll show how to do that. So Horizon, double click that, go to read data, and open the folder, and you see a file, double click that, and it will show the experiment with a raw data file. So you can see the full picture by going to the ITT final figure, and this is the full file. So you can actually fit it with one binding site or two binding sites, depends on how many binding sites you have on your data file. So you can just, let us say, one data file, you can fit it. Keep on hitting this one itinerary until unless you get the ideal block. And then so this is how you fit the data, and you get all the binding parameters which are there.
This is a demonstration of how to use the Perkinometer 341 colorimeter. When you come to the instrument, it should be on, so the first thing you want to do is turn it on. After you turn it on, it should go through its initialization and warm-up procedure. If you're measuring a normal wavelength, which is 589 using a sodium lamp, it won't take very long to warm up, and pretty soon it should show 0 degrees. If it's showing something very different than 0 degrees, you can re-zero it just by clicking on 0. One thing you can check is the energy, so if you press the energy button, you can see the energy, and that's how much light is getting through the system, so more energy will give you a better signal, so there'll be less noise. If you're doing another wavelength, you'll probably need to use the mercury lamp. So to do that, what you would want to do is click wavelength, and then use the arrows to select a different wavelength. So for example, let's go to 578 nanometers, click enter. It will switch to 578 nanometers, and then it says mercury lamp is switched off. So I'm going to press the mercury button to turn on the mercury lamp igniting. Now be aware that the mercury lamp takes a long time to warm up. So if we look at the energy over here, you'll see that it's quite low, and that it's slowly ramping up. So you'll probably want to give it a good 5 minutes to warm up before you start taking measurements if you're using the mercury lamp. But normally we just use a sodium lamp, so I'm going to turn the mercury lamp back off. And then we're going to go back to the standard wavelength. And there we go, it's ready to go. Okay, so to measure rotation of samples, you need to put it in a colorimeter cell. Colorimeter cells are 10 centimeters long. There's different diameters of cells. This is one holds 10 milliliters. Larger ones will allow more light throughput and a more accurate measurement, but of course they use more sample. So you'll want to fill the cell. You want to make sure there's no debris in there, there's no bubbles in the cell, and once you've got the sample in the cell and filled, then you want to put it into the instrument. So open the door. The larger cells can sit directly on these rails here, but for the smaller cells you want to use this aluminum holder, and just put the sample cell in the holder, close the door, and it will adjust to figure out the rotation. This is a sample of glucose, so it should have some significant rotation, but we don't know the concentration exactly, so we don't know exactly what the rotation should be. Okay, so we've got the reading. Once you've got the reading that you want, if you want to try to get a more accurate reading, one thing that you can adjust is integration time. This is how long it integrates before it makes each measurement, so we can go from 2 seconds to, let's say, 5 seconds, and that may allow a more stable reading on the rotation. Okay, so once you're done, you'll want to take out your sample. Let it go back to 0. If it doesn't go back to 0, that may be an indication that there's a problem with the instrument, so let me know if there's a problem. But in this case, it went back to 0, so we're fine, and then you can shut it off. And please log your usage on the clipboard. We don't normally require you to reserve time on the website to use this, so if you come up and use it, please don't forget to log your time.
Today I'll be demonstrating time-correlated single photon counting, or TCSVC, using the Borlaug by Gibbon Bond. So the first thing you'd like to know is the peak excitation and emission of the organic dye you'll be looking at today. We'll be using electroporation and duplex DNA. So I need to make sure that my point source is the proper wavelength. You see here, this is 390, so this won't work. You need to change out your point source. We have several point sources here to choose from. I need 459. So to remove the nano LED that's already on the instrument, this is the test screw, and pull the plug. You can take the next one. So the right here is 459. Place it in the instruments, tighten on the test screw, and put the plug